The least squares regression line criterion leads to the following formulas for obtaining the least squares regression line. The least squares regression line. The equation of the least squares regression line is given by the following. We have y hat, which is equal to b subscript 1 x plus b subscript 0, where b1 is equal to r times the standard deviation of y's divided by the standard deviation of the x is the slope of the least squares regression line. And b subscript 0, which is equal to the y mean minus the slope times the x mean, x bar, is the y-intercept of the least squares regression line. And now keep in mind that r represents the linear correlation coefficient, x bar is the sample mean, and s subscript x is the sample standard deviation of the explanatory variable x. Y bar is the sample mean, and s subscript y is the sample standard deviation of the response variable y. Okay, so again, we have our formulas there for the least squares regression line. Now, what are the key ideas about the least squares regression line? Well, the least squares regression line always contains the point x bar, y bar, meaning that it always has the sample mean for the explanatory variable and the y sample mean for the response variable. Now, because the standard deviations of both the y and x must be both positive, the sign of the linear correlation coefficient r and the sign of the slope of the least squares regression line b subscript 1 are the same. Okay, so again, b subscript 1 represents the slope. So we know that that represents the slope. Okay, now the predicted value of y hat, is an estimate of the mean value of the response variable for any value of the explanatory variable. Okay, so let's take a look at this example. Finding the least squares regression line by hand, find the least squares regression line for the data in Table 2 from Section 4.1. So for convenience, we also provide a scatter diagram of the data. In example 2 of section 4.1, we found that r was equal to negative 0.946. The sample mean was 4. The sample standard deviation of x was 2.44949. The y mean, or the sample mean for y values, is equal to 10. And the sample standard deviation for y is 5.612486. So we're going to use these values and then substitute those values into the slope formulas for the slope and the y-intercept of the least squares regression line. So here is the formula. Remember that b subscript 1 is equal to r times the standard deviation of y divided by the standard deviation of x, and the y-intercept is b subscript 0, which is equal to the mean of the y values minus the slope times the mean of the x values. Now note, when using statistics and formulas, carry as many decimal places as possible to avoid round-off error, meaning that when you're plugging it into the formula, keep as many of the decimal places as you can, and then at the very end, when you're done with your calculations, then you can then round accordingly. So, now in the first one, we're going to find the slope. So the slope is equal to the linear correlation coefficient. So recall that the linear correlation coefficient is negative 0.946. So we're substituting that in for r. Okay, and then what else do we know? We also know that the standard deviation for the y values is going to be in the numerator, so times, and that is 5.612486. And then we're dividing it by the standard deviation of the x values, which is 2.44949 here. Okay, and so when we plug this in, the best way to plug this in, and I'll show you here, is to calculate, multiply those two together, and then divide by the denominator. So we're going to take negative 0.946, multiply it by 5.612486, and then we're going to divide it by the denominator of 2.44949. And then we get negative 2.1676 when we round it to 4 decimal places. Okay, so that gives us the slope. Okay, next, we now want to substitute these values for the y-intercept. So we know that the value of y bar is going to equal 10. So we're going to put 10 in for y bar. Okay, and then we know we're going to subtract the slope that we found in the previous step. So we know that the slope here is minus negative 2.1676. Okay, and then we're going to multiply that by the mean of the x values. So we know that the mean of the x values is 4. So we have 4 there. Okay, so now let's go ahead and do that. So we're going to take our 10, we're going to subtract, and then parentheses, negative 2.1676, and then we're multiplying that by 4, and that gives us 18.6704. So now, recall that we know that the formula for the least squares regression line is y hat, which is equal to the slope times the value of x plus the y-intercept. So looking at the information that we got, we know that we end up getting the slope of B1 to be negative 2.1676. So there is the slope of that line times x. And then plus the y-intercept, which is 18.6704. Okay. All right, now rounding the slope and y-intercept. Throughout the course, we agreed to round the slope and the y-intercept to 4 decimal places. In the last example, we found a least squares regression line by hand. Why? Mainly to see the role that the correlation coefficient r, the standard deviation of y, and the standard deviation of x play in finding the slope. Plus, from the y-intercept formula, we learned that all regression lines travel through the point x bar, y bar. However, in practice, the least squares regression line is found using technology. So, for example 3, finding the least squares regression line using technology, we're going to use the golf data in table 1 here. We want to find the least squares regression line. Okay, so the first thing I'm going to do is I'm going to open up the data in StatCrunch. So here's the data. Okay, so now that I have the data, the first step is they want us to find the equation of the least squares regression line using technology. Okay, so the first thing that we're going to do is we're going to select stat, and then we're going to go highlight regression, and then we're going to select simple linear. Okay, now once we do that, we're going to choose the explanatory variable for the x variable. So we know that that's going to be the club head speed because that is the x variable. And we know that the y variable is going to be the response variable, which is the distance. So that should not be speed, it should be distance. And I'm going to go back and I'm going to correct that column up here because it should say distance. Okay, so again, we're going to go back to stat. We're going to go all the way down to regression and then select simple linear. Okay, now again, the x variable is the club head speed and the y variable is the distance. Okay, and so now what we want to do is we're going to scroll all the way down to the bottom. We're going to leave everything else alone. Okay, and then what we're going to do, now it says here that if you want, we can enter, if you want the least squares regression line drawn on a scatter diagram, we're going to highlight fitted line plot under the graphs. But we're not going to do that yet because we're going to go and draw the line on the scatter diagram of the data. So the first thing we're going to do is going to go ahead and select compute. Okay, and so when we select compute, I'm going to take this data and I'm going to copy it. Okay, so that we have everything in here. Okay, so let me make sure that we can see all this information. Okay, so let's go ahead and copy this information here. Okay, now we want to analyze this information before we go any further. Okay, so up here at the top, it says we have the dependent variable, which is distance, and the independent variable, which is club head. So you want to make note what those represent. Well, that means, remember, the club head, which is the x variable, and then this represents the y variable. Okay, and so here, what it's telling us is the following. Okay, it's given us the slope and the y-intercept. So if you look here, this represents the information here. This is considered the standard error, but this represents the intercept and the slope. So what that's telling us is that the slope from our StatCrunch is telling us that it's 3.1661. We're rounding that to 4 decimal places, as we said earlier. And then the y-intercept is going to be negative 55.7966. Okay, so that's telling us what the slope and the y-intercept is. And recall that the regression line is equal to the slope times x plus the y-intercept. So therefore, our line is going to be the following. It's going to be y hat, which is equal to 3.1661x minus the intercept of negative 55.7966. Okay, so therefore there is our regression line. And you can see that it's the same thing up here. Okay, so the line is listed right here. Okay. All right, now what we want to do is we want to then now be able to draw the least squares regression line on the scatter diagram of the data. So what we're going to do is we're going to come back in here, okay, and we're going to select our options. So there is our line and it's fitted. So if you look here, there is our regression line. So moving to the next slot on our information down here, we end up getting the graph, and then that line represents the best fit line. So I'm going to go ahead and then view this line, and what happens is you can see that this line, okay, is the best fit. And so that line, that's the red line, represents the line of best fit, which is what we have here. Y is equal to 3.1. Write that again. Y hat is equal to 3.1661x minus 55.7966. Okay. Okay, now it says predict the distance a golf ball will travel when hit with a club head speed of 103 miles per hour. So when they're asking us to predict, that means that the value of the club head speed of 103. So that's telling us that x should equal 103. And we're going to plug it into that equation. So y hat is going to equal 3.1661 times the value of 103 minus 55.7966. So let's go ahead and then calculate that on our calculator. So we have the following. We have 3.1661. We're going to multiply it by the value of x, which is 103. And then we're going to subtract 55.7966. Okay, so if you notice here, it's going to give us 270.3117. So 270.3117. Now we're going to round that to 1 decimal place, And if we round it to 1 decimal place, you will see that the predicted distance of the golf ball will travel 270.3 yards. Okay, now what we want to do is we want to determine the residual for the predicted value found in part C. And the question is the distance above or below average among all balls hit with a swing speed of 103? Okay, so how do we figure that out? Well, remember that the residual formula is equal to the observed Y value minus the predicted Y value. Okay, so what do we know about the predicted Y value? Well, we know that it's the predicted Y value we just found in that last step to be 270.3. Now, if we go back to the observed value, meaning that this is the observed value, so for 103, what was the Y value? So for 103, we could see that the Y value is 274. And let me use a different highlighter here. So the Y value is 274. So therefore, we take 274 and then subtract 270.3, and that equals 3.7 yards. So because the residual is a positive value, the distance of 274 yards is considered above average for a swing speed of 103 miles per hour.